A review of volcanoes. A volcano is a rupture in the Earth's crust which allows magma or ash or gas to escape from beneath the Earth's surface. When magma reaches the surface of the Earth, it is called lava. Most volcanoes occur along or near the margins of tectonic plates, where plates move away from each other or collide. What comes out of volcanoes? Lava. The chemical composition of the lava will determine whether an eruption is explosive or more gentle. When gases can escape easily, the eruption will be less violent. Lava can be very viscous. Explosive particles. Hot fragments of lava that are ejected by volcanoes cool as they fall through the air. These pyroclasts range in size from very large bombs and blocks to fine ash or tephra. Pyroclastic flows. A mixture of hot gas and tephra that can flow at hurricane velocity. Lahars. Slurry flows of ash and tephra which flow from a volcano. They have roughly the consistency of concrete. A divergent plate boundary, or constructive plate boundary, is where oceanic plates move away from each other and hot magma rises and cools to form new crust. That means most volcanic activity occurs under the sea. Where there is a lot of activity, volcanic material can build up above sea level, forming an island, such as Iceland. A convergent plate boundary, or destructive plate boundary, is where oceanic lithosphere, the crust and upper mantle layer of the Earth, sinks back into the mantle, often forming a deep ocean trench. The volcanoes that can form near to these trenches are amongst the most dangerous on the Earth because they are typically explosive and many are located near populated coastlines. In the middle of plates, volcanoes sometimes occur. Some geologists think this is because of a hot mantle plume or hotspot, which creates chains of volcanoes as the plate moves over them. The Hawaiian Islands are the best known example. Volcanoes in the UK? Yes. Great Britain no longer has active volcanoes, as we are now in a tectonically quiet part of the world, but we had an eruptive past. You can still see evidence of volcanoes in the Lake District, Snowdonia, northwest Scotland and Northern Ireland from eruptions that happened millions of years ago. Did you know ash blasted into the atmosphere during an eruption may cause intense thunder and lightning? Major volcanic eruptions eject sulfurous gases high into the atmosphere, causing temporary cooling at the Earth's surface. Volcanoes also emit carbon dioxide, but only about 1% of what human activities add annually, so not enough to contribute to global temperature rise. Also, despite the danger, millions of people live close to active volcanoes, sometimes through lack of choice. Chemical weathering of volcanic deposits can release minerals that become a natural fertiliser. One example is the intensely cultivated area around Naples in Italy, which has the eruptions of Mount Vesuvius to thank for its rich soils and top-quality fruit and vegetables. So can we predict an eruption? Because they are hazardous, volcanoes need to be monitored. Unlike earthquakes, it is possible to predict a volcanic eruption. Earthquake sensors, or seismometers, and gravity meters can track the movement of magma and gas to the surface. The swelling of a volcano can be monitored using tilt meters, laser rangefinders, and global positioning systems, GPS equipment. All this technology means prediction is getting more accurate, but it's still not perfect. Volcanic eruptions are classified on a numerical scale called the Volcanic Explosivity Index, VEI. This goes from 0 to 8.